Gentlemen, welcome to Tech Geek Webinars, our endeavor to empower techies. Today's session is third in the Advanced Java series, and topic for today's webinar is Java Design Patterns, Useful Variations in Singleton Pattern. We are delighted to have Mr. Hemant Kumar Dugar, Training Consultant at Login to Java with us today. Hemant is a motivated achiever with more than 15 years of significant progressive experience in IT. PMP certified professional, having a sound base for core concepts in managing projects and processes at various knowledge areas. Having extensive knowledge of managing projects using various PM methodologies. Equally sound in technology with more than 7 years of hands-on development in OO environment, while most of the projects worked were in Java, J2EE and related technologies, and he has also completed some of the finest works in C# and PHP. Gentlemen, this presentation will continue for next 45 minutes and we'll take your questions after the presentation. In the meanwhile, you can post your queries to the chat pane available in the webinar software. Without further ado, I introduce you to our guest speaker, Mr. Hemant.
Just wanted to confirm that am I audible?
Yeah, Mr. Hemant, you are audible and we can see your screen also. Please go ahead.
Okay,
Thank
sure. Thank you. Hi everyone. Welcome to the session for Singleton Design Pattern. So we have a mixed entry with some freshers also. So I will start with the introduction to the design pattern in brief, and we'll start drilling down the Singleton pattern later on. Now, I will have these topics today, design patterns and Java, drill down the Singleton pattern, discussion on Singleton variations and suitable situations where each fit, a real-life programming example, some question answer session, and we'll discuss few possible interview questions also. So if you want to define the design patterns, there can be a few definitions. Some of them are here. Design patterns constitute a set of rules describing how to accomplish certain tasks in the realm of software development. In other words, you can also say a pattern addresses a recurring design problem that arises in specific design situations and present a solution to it. In other words, we can also say a pattern is a global solution to common design problems such that you could use the solution many times and never quite use it the same way twice. If I had to take an example for this in some real life, so you can say suppose there is a recipe for some say Hyderabadi biryani. So that recipe includes some objects as you can say ingredients for that particular dish. So all those ingredients and each ingredient, when that ingredient will be used while preparing the Hyderabadi biryani, with each of the ingredient, if required, some processing will be done over it. So the whole recipe itself is a pattern. You follow that recipe and you can prepare the Hyderabadi biryani. So this is one very simple example. In computer programming, the term pattern was first coined by Christopher Alexander in around 1977, that is relating to use of pattern in architecture. The use of pattern in object-oriented context is very recent, with a vast majority of work done somewhere around 1994 it's started actually. In object-oriented design, there may be many implementation solution possibilities to a given problem. So before we start discussing object-oriented, I will take an example, or I will discuss on procedural programming languages like C. Excuse me. If you are programming in C, so what you do, you break down your module into smaller tasks, break down till you get a task that accomplish a unique, single unique purpose. So this basically advocates for the reusability. If you want to use, and you create a function for each of the individual tasks and then call that function maybe with some parameter and take a return value from that module, from that function. If you want to use all those functions in the same program, it's fine. You can put all those functions in a separate portion of your program file. But if you want to use some of the functions to the different program, you need to make a header file out of it and then use that header file. So in procedural programming language, the pattern is very simple. But when it comes to object-oriented patterns, there are many things that comes with the object-oriented, classes, objects, interfaces, inheritance. So this makes the thing more like real-world objects or real-world classes or objects. So in object-oriented, there may be many implementation solution possibilities to a given problem. So a pattern may be helpful for a wide range of similar problems to which the pattern solution is mapped. Now, how patterns add to object-oriented? Common problems while designing: assigning responsibilities to software components appropriately, which class is responsible for handling particular event, which class should perform particular action, problems while creation of suitable objects, abstractions from the problem specification, and many more such problems you came across in your day-to-day programming. So after years of software creation in industry, a developer acquires knowledge of certain guidelines and heuristics in object-oriented design, and patterns formalize these principles. So future developers do not have to learn them the same way. So as a developer, you come across many such situations when you have been using, for example, connection pool, cache management, or some producer consumer while using threading. So for those situations, there are patterns, and if you know those patterns, that particular knowledge helps you in creating a robust code. Well-tested and proven solution templates, well-planned object modules are actually logical, robust, maintainable, expandable, and reusable. So lots of advantage with design patterns. Leads to faster development, faster, easier, and improved communication. This is one of the good example, good advantage, you can say, for the design pattern. It improves communication. How it improves communication? You can imagine a meeting between developers, a team, technical team members is going on. There are 4 or 5 members attending that particular meeting. So at a particular situation, if team lead says you can use strategy pattern over here. So just by saying a few words, everything gets communicated. And if the team doesn't have knowledge of design patterns, then I suppose it may take much longer time to first explain the things how the strategy pattern should be. Or if even you don't know strategy pattern, there are many other ways to complete that particular thing. But because the strategy pattern is proven, definitely it is the best solution. Otherwise, your code may not be that robust. And it may take also time during coding as well as maintaining the code, including the more time that you spend in the meeting. Then improved code understanding overall reduces cost of development and maintenance. Design patterns and Java. It is helpful to learn design patterns in your language of choice. Java is more strict to its object-oriented prospects. We'll see that Java interfaces and abstract classes, Java interfaces and abstract classes are a major contributor to how we build the Java design patterns. Remember, design patterns can exist at many levels, from very low level specific solution to broadly generalized system issues. Hundreds of patterns already in literature. Some have wide applicability. If you see, 20% of design patterns are used 80% during the programming situations. So there are a very few patterns that normally used in day-to-day programming often. The process of looking of these patterns are basically, you can say it is known as pattern mining. Most patterns are discovered rather than written while programming, experiencing through coding. Patterns may be nested. You can use one pattern, the same pattern within the other pattern, or different patterns together forms a new pattern. A pattern solution may therefore be of any size. This is very important. With its component problems solved by more specific patterns. Classification of design patterns. Basically, there are a few classifications like fundamental design pattern, creational, structural, behavioral, partitioning, and concurrency. Fundamental design patterns. Actually, these are fundamental in the sense that they are widely used by other patterns or are frequently used in large number of programs. Delegation, interface, abstract superclass, interface and abstract superclass, immutable, and few more. Creational patterns are ones that create objects for you rather than having you instantiate objects directly. Normally, a developer prefer to use new keyword to create objects, but actually in real practice it is much better to avoid new keyword while creating object. Instead, use some creational pattern for the more robust and maintainable code. This gives your program more flexibility in deciding which objects need to be created for a given case. So these are a few names of the creational patterns: factory method, abstract factory, builder, singleton, and few more. We'll look into detail for singleton after this session, after this introductory session of design patterns. Structural patterns. Structural pattern helps you compose groups of objects into large structures, such as complex user interfaces or accounting data. Adapter, iterator, bridge, facade are some of the structural patterns. Behavioral patterns. Behavioral patterns helps you define the communication between objects in your system and how the flow is controlled in the complex program. Chain of responsibility, command, mediator, state, strategy pattern, and few more. Partitioning patterns are basically, say in web application, both the client and the server are capable of executing logic. So the client through the JavaScript and the server through the server-side scripting such as Java. So there are several factors that dictate the partitioning of application logic between these two tiers, or maybe between tiers. If you are using communication, you need to use partitioning pattern for a better code. Filter, composite are examples of partitioning pattern. Concurrency patterns. So as the languages advances, most of the languages or technology now allows multi-threading, and there are several problems while working with multi-threading. So if you use well-tested patterns while working with multi-threading, it will reduce a lot of headache for managing multiple threads. So focus on two kinds of problem, mainly the sharing of resources or focusing on deadlock management and concurrent execution of operations. These patterns present generic solution to frequent occurrence problems found in concurrent and distributed systems. Single-threaded execution, producer-consumer, bulking, and some other also available patterns for multi-threaded environment. You can classify them as a concurrency patterns. So this is a brief introduction to design patterns. Now we will start with Singleton pattern. Singleton pattern actually comes under creational patterns. Creational patterns deals with the best way of creating instances of objects. Your program should not depend on how objects are created and arranged. In many cases, the exact nature of the object that is created could vary with the need of program. There are cases when there is no need of creating an object. There are cases when only one instance of class is required. So these are the reasons why we have creational patterns. Abstracting the creation process into a special creator class can make your program more flexible and general. These are the few names of the creational pattern, and now we will look into details of Singleton design pattern in Java. Singleton pattern is a class of which there can be no more than one instance. It provides a single global point of access to that instance. Problem definition. In nearly every application, there is a need to have an area from which to globally access and maintain some type of objects. These are also case in object-oriented systems where there should be only one class running at any given time. If you just think of your programming, when you do programming, connection pool is an example. You normally have a single connection pool throughout your application. Window manager, only a single window manager is used in any of the application. Are few examples. So what we can say is some classes should have exactly one instance. These classes usually involve the central management of a resource. The resource may be either internal or external. And as we saw, window manager, print spooler, database engine, only one audio clip is played at a time. In your system, normally when you play an audio clip, only one audio clip is played at a time. If you start second, it stops the first one and starts the second one. So if we do the requirement analysis, there must be at least one instance of class, even if all members are okay. Here you can think why we need a single instance if we can done it. We can have things completed by a simple static class. Static class means when all the members are static, you can define it as a static class where all the methods are static, all the data are static, and you can use that. But what if we need an instance because of maybe situation to pass a method to another class? We need an instance if we are implementing an interface, because static class cannot implement interface methods. So you need a single instance for in that particular situation. We will see some examples. There should be no more than one instance of class, and the only instance must be accessible to all the clients of the class. Now, clients. Client here means the module or the program that is using the singleton class is the client. So client is user of user program, user code of that particular singleton class. So in general, singleton pattern is to ensure a class has only one instance and provide a global point of access to it. So how it can be implemented? Just think of it, you can come to close to the solution. A static variable that refers to the only instance of the class you want to use. This instance is created when the class is loaded into memory, or it can also be lazy initialized. Must define at least one constructor. All the constructor must be private. Why all the constructor must be private? Because we don't want that client application can create direct instances using new keyword. So all the constructor must be private. Must provide a static method that returns the reference to only instance of the class, typically called getInstance. GetInstance, or you can say get the only instance, or instance, whatever name you want to give, you can give this to this particular method, static method. But normally getInstance is used. If you want to see some Java example, I think Java example can be okay. Let's see Java example. Just think of runtime. Runtime class is there in Java where there is a method get runtime. That get runtime will return the only instance of the runtime environment within your JVM. So that is a singleton implementation in JDK. So the class diagram is the simplest one. Only one class is there. This is a static unique instance, singleton. The class name is singleton, and singleton data is there, which is basically the requirement or the usage of this particular singleton class. And there is one method, static method, that is get instance. Other methods you can have for the operations and for getting and setting the data. So the required things are, even singleton data is also not that important, but two things are important that you should have is a static instance and a get instance method. But normally you have data within your singleton class. So Java API example, as I said, java.lang.runtime is a singleton class. It has exactly one instance. There is no public constructor of it. You cannot create an instance of runtime through new keyword because all the constructors are private. Method get runtime is used to get its only instance. Now let's see one example. An AudioClipManager. This class can be used to avoid playing two audio clips at the same time. The class has only one instance that can be accessed through its getInstance method. When you play audio clips through that object, it stops the last audio clip it was playing before and it starts the newly requested one. If all the audio clips are played through the AudioClipManager object, then there will never be more than one audio clip playing at the same time. So we need to create an AudioClipManager for this requirement. So how the AudioClipManager should be? Implements audio clip. There can be there is an interface that this manager is implementing. That interface can have a method like play and stop. It has a private static audio clip manager, my instance, the only instance, and as soon as this class gets loaded into the memory, the instance gets created, new audio clip manager. This is the only constructor that is private, which is used within this class to create the only instance. So you are not allowed, or client application is not allowed to create its instance using new outside or within the client application. Now this is a data that stores the clip, and this is the method that returns the only instance, getInstance method. I think it is a very straightforward singleton implementation for AudioClipManager. Implements audio clip because audio clip needs some common operations for playing, stopping, rewinding, forwarding audio clip. Then there is a single instance, only instance, and there is a getInstance method. Now see another variation. Just have a look for a few seconds and think how it is different from the previous one. We are not creating object over here. This is, we are assigning null to it. It means we are not creating object when this particular class is loaded into the memory. Instead, we have getInstance method that checks for myInstance is equal to null, and then it assigns the it creates the instance and assign it to the myInstance variable. So this you can say a thread safe version for AudioClipManager. But isn't it thread safe? The previous one, it is also thread safe because the instance gets created as soon as the class is loaded, and this is the only instance. So if number of threads are accessing this particular method, still the same instance will be returned. So this is thread safe. Again, this is also thread safe. What is the difference? The difference is early initialization and late initialization. In this particular example, the instance is created as soon as the class is loaded. So it is early initialization. Whereas in this variation of singleton, this is late initialization. When the class gets loaded, there will be no instance. When this particular method used for the first time, it will create the instance. So just to give you a small introduction to lazy initialization, in many applications it is required to do lazy initialize. Suppose there is a class, while creating its instance, it requires to acquire lot of resources which consumes time, and you want that your application should start fast, as fast as possible. All the classes and objects are not required at the start of the application. Some are required when a particular request we send to the application. So we do lazy initialization. Lazy initialization allows application to load faster. And then when we require particular object, through the application interface we send the request. At that time the object will get created. So we have these two variations, early initialization and late initialization. Now this is the AudioClipManager code to use the singleton. So if you go through the code, there is a method play. It will check for if previous clip is not null, continue to play the previous clip. And this is a play method where you can send a new clip and it will stop the previous clip and start playing the new clip and make the clip as previous clip. Then there is a loop and then another loop and then stop method. So this is the code. We are not much, we should not much worry about this code because we are studying at present the singleton pattern. Now another variation in singleton. If you are sure that you don't require any instance and you need much, your concentration or your requirement is mainly on the performance, you can say a static class as a singleton. We can say a class is static if all the members of the class are static and the only default constructor must be private. Why it must be private? Because we don't want to allow creating instance of this particular class. And the class must be declared final. Why to declare final? Because we don't want that it should get inherited. Because if we do not use this final keyword with the class declaration. Subclasses can be created out of it, and the instance will exist within the subclass instance. So we should declare the class as final. So there is already a kind of singleton class in the standard Java class library. If you have used math class, I think most of you must have used the math class. It is a static class. You always use math dot. So its purpose is to wrap the number of common mathematical functions, and actually instance is not required for this, but the performance is required. And static class and methods within the static class are much faster than the methods that execute through the instance. So math class is created as a static singleton class. The advantages are better performance. Disadvantage is basically, you can say, lots of reprogramming effort required to drop the singleton behavior. Suppose we want instance of math class. So in that case, lot of reprogramming is required throughout the code wherever you are using math class. So actually, you must be sure before using static class as a singleton. You must be sure of you don't require any instance, you are not going to implement any of the interface, then go for it. Any instance means instance subclassing also you don't require, and also you don't require to implement any of the interface. So if it comes under this scenario, go for static class as a singleton. Other consequences, you can easily change the singleton to allow a small number of instances where this is allowable and meaningful. So there can be situations where you need 2 instances or 3 instances that you can control through some of the static counter within the class. It can be difficult to subclass a singleton, since this can only work if the base single class has not yet been instantiated. So if you want to subclass the singleton, you should your implementation should support that the instance of the subclass will be created only when the base single class instance has not yet been instantiated or created. You can use singleton pattern with many other patterns. In particular, it is often used with abstract factory builder prototype patterns. In cache management, a singleton is functionally similar to cache that contains only one object, and object pool, managing an arbitrary large collection of similar objects. So these are a few of the patterns that require or might need singleton pattern to work with. Now just go through this problem and think how you can implement this. Application context. I think you must know about this word, application context. You must have used in some of your application. In most of the web application, all the frameworks provides application context where you can put your data throughout the application life cycle. So there can be only one application context that can exist in an application. So you can easily imagine that application context is a singleton class. Most of the application server provide application context with their framework implementation. But suppose you are developing a desktop application from scratch, you need to create your own application context. So give it a thought, and you have to just think, you have to create an application context, how it should look like. Application context is an object that stores data required throughout the application execution lifecycle. There must only be one instance of this object. It should have methods set or get and remove application wide objects. So normally you need a key pair value where key is string and value can be any object to set into the application context and to get from the application context. And in case if you want to remove that object, you can have a remove from the application context. The application wide object should be accessed by a key of type string, and value normally be either your required object or can be object, any object. So how this can be implemented? Just think of it. I will show you an example. So I have already created my application context and I am using that my application context in my Singleton demo. So my application context ctx is equal to my application context dot get instance. I am putting some data, put data, ctx dot put data, hello world, hello world. So this becomes the key and this becomes the object. Another data where key is singleton, this is a singleton pattern, this string is data. And now I am putting key as time and a calendar object. And now this is the portion where your rest of the program goes. So in case if you require this particular instance again in your applications at some other location, your code should be similar to this. Just my application context ctx02 some other reference, and then you can call the my application context dot get instance method. So this particular method will return the same instance where you can get the data out of your application context. So this is the use of my application context, and if I run this program, you will see these object gets printed on the output window. Here is the output. So it works well. Now let's look at the my application context. Now if you see, this is static my application context, and I have created early initialization. There is a map that will keep key and value pair of objects where key is string. This is only a constructor which is private, and it creates the hash map instance for this particular map app data. Then we have a static method get instance which returns this application context, and then get data, put data. Similarly you can have here remove data also. So this is a very simple implementation. Now can you tell me what will happen if this is a heavy operation? I mean to say your application needs to be loaded faster, whereas my application context is somehow a costly object. It is having different operations, different resources somewhere over here. we need to do a lot of processing, suppose over here and here, and it takes time, and we need to load our application faster. So what should we do? The lazy initialization. So let's make the change in this code for lazy initialization. What I should do is, I want to initialize when the class loaded. Instead, what I will do is, so I'm not creating object over here when the class loads. Instead, I create object when there is a first call to get instance, and during the first call, app context, app ctx will be null, and it will create a new instance and will return. But this is not suitable for multi-threaded application. This is another variation. If you are sure that your application is a single threaded application, this is going to be the best solution for the lazy initialization of Singleton. But if your application is multi-threaded, you need to put synchronized keyword over here. So this is lazy initialization. Okay, but now think of, a lot of work is going on within this method, or maybe the synchronization is happening on this method, whereas we need to synchronize only this particular portion. That is actually creating the object. So how we can do it? Again, I will let you explain it again. Suppose there are lots of threads accessing this particular method. Only the first thread actually checks for the null and create instance. All rest threads are not null. This condition will get false and the only instance will be returned. But all other thread unnecessarily accessing the synchronized method. That is not needed because synchronization is an overhead. So what we should do is, instead of using synchronized keyword over here, what I can do is I can just synchronize this block. Synchronized my application context.class. And put this line inside. So the first thread, when enters into this method, it will found this null and enter into the synchronized block. Suppose there is a second thread entered simultaneously within this particular method, it will wait over here in the synchronized block. So if the first thread comes alone, this is okay, but this is a faulty implementation. Why? If 2 or 3 or more threads enter simultaneously, all will be null initially. So all threads will wait over here. Only one thread will given access with inside the synchronized block, and it will create the instance. When that particular thread move outside of the synchronized block and another thread will be given access to the synchronized block, it will again create a new instance. So we have to check double over here. So I have to give another condition over here. Now, if suppose there are more than one, suppose 2 threads are accessing for the first time, and one thread is given access to the synchronized block, whereas the another thread is waiting for its turn. So the first thread will have appctx null, and it will create a new instance, and it leaves the synchronized block. As soon as it leaves, the second thread will be given access to the synchronized block, and now appctx is not null, so it will go directly. So this problem is resolved. Now the question that comes in mind of many of the attendees over here is why this condition is required. We can have just this particular block. So this condition is again required for the performance improvement. We call it as double check. How it improves the performance? Say, imagine a website where thousands of users or hundreds of users accessing simultaneously, and every user needs this application, every user's request needs this application context. So there are 100 threads accessing simultaneously get instance method, and if we don't have this particular condition, it will be a bottleneck over here. So are you getting me? There are many threads entering into this method. If we don't have this condition, all threads will be waiting here, only one thread will be given access. After that, remaining thread one by one given access into the synchronized block, and that will degrade the performance of application. So as soon as we have the application context, this condition holds true, holds false, and remaining thread without entering into synchronized block will return the application context. So this is a tremendous performance improvement for a website that is very busy. So we need to double check over here. So this is another variation. So depending on basically the requirement of your application, you can use the singleton variation. Let's see how many variations we have seen till now. We have seen static singleton like math class in JDK, Java. Singleton with early initialization. Singleton with lazy initialization. Singleton for single threaded application normally with lazy initialization. And high performance singleton with late initialization, the last one. So these are the few singleton variations that can be used depending on your application requirement. Let's discuss a few of the possible interview questions on this. One is multiple instance arising when someone has subclassed your singleton class. How you can avoid such instance? Subclass your singleton class, like my application context. Anybody can inherit it. So what you can do is put a final keyword in the class declaration. It will not allow you to create subclasses. Now create a copy of object by cloning it using the object's clone method, because clone method is in object class, so anybody can clone. So how you can avoid this to happen? So you should overwrite the clone method in your class either through the exception or return the same instance. Similar situation can happen if you serialize your class and deserialize it again. That will again create a second instance, or as many times you deserialize, you will get a new instance of it. So how you can handle this situation? So you can do it by overriding read resolve method. Read resolve method, you can override it to return the only instance or the same instance. So doing overriding the read resolve method, you can avoid to have another instance while deserialization. Now let's have a question answer round.
Questions are already shared with you.
Okay, let me see. What are the possible design problems? If we talk about singleton pattern, I think we have discussed most of the possible design problems for the singleton, and we have seen around 5 variations of the singleton pattern. Is it possible to have singleton pattern implemented in clustered environment? I think in clustered environment also we will be having multiple JVMs running. So we have to look into the object, same object copied on clustered environment, and we should basically observe the change in one of the object. If it happens, should be reflected in all the clustered environment. If I remove synchronize, what happen? It's still thread safe. Yeah, I have discussed this during the session that it is possible to remove the synchronized keyword, sorry, not remove the synchronized keyword. The early initialization variation of singleton is always a thread safe implementation that we have already discussed, because the only instance is already created when the class is loaded. So there is no need to synchronize the get instance method. Same question. Can we use single valued enum as singleton? Enum are not classes actually. They don't behave like class and objects. So if you think of application context, can you think enum can be used to create application context? I don't think. Can we maintain a single instance when we deserialize a previously serialized singleton? I have already told that you need to override read resolve method to return the only instance. Why are you putting lock in the class? I think this is basic Java question, because that method is a static method, so you need to acquire lock on class. Can the myApplicationContext.class be replaced with this? This is similar question that Dipesh has asked. This is from Raghav. We cannot, because the method is static method. Shouldn't we mark class as final? We should mark class as final. I have discussed this in the later slide. If execution environment supports multiple class loaders, then you get one singleton per instance of your class. If your singleton class is this, I think the implementation will be similar to the clustered environment that I have already replied. Kunal Bindal, how can we limit the number of threads being created? This is not related to singleton pattern. This actually should come under concurrency patterns. Which classes are candidate of singleton? Which kind of classes do you make singleton in Java? Arjun. Candidate for singleton. I didn't actually get the question, because this is basically a program requirement to have a class singleton or not. I have taken few examples: AudioClipManager, application context, even Java has runtime class. Again, Arjun has asked why the lazy and early loading of singleton and how will you implement it? I think I have discussed 2-3 times during this session why we are when we are using lazy and when we are early. So actually it actually depends on your application requirement and the object, the singleton object, whether it's a resource incentive or it's consuming time while creation. If it's consuming time while creation and you want your application to be loaded faster, you should do lazy initialization. And if your only object, even it is taking time while creation, but it is required as soon as your application is loaded or even before that, you should have to do early initialization. As per object-oriented programming concept, is it a better practice to have global data in the form of singleton? This is from Chintan. Global data are never advised in object-oriented programming. If you need any global data, make the data private, give access to get data and set data method. That is the best practice. Singleton is entirely on a different situation. But if you are asking about global data for singleton purpose, I think it is not maintainable, because if you work in a team environment where a project is running over a period of time and your global data can accidentally be changed, so that is not advisable. Can I write to creating the instances in a static block? Yeah, definitely you can have a static variable, create instance and assign it to static variable. We have already seen working example I have shown you for the application context. What is double checked locking in singleton? This is again I have told double checked. Why we did the double check? Okay, let me explain it a bit again. Okay, let me show you this screen. Why we are doing this double check? Actually, this condition will work in normal case. The synchronization block and this condition will work. But why I have put this particular null check? Because I want multiple threads to bypass this synchronized block to give the better performance. And simply by checking application context is equal to null, if the condition is false, it will return application context bypassing this synchronized block. That's why we are doing the double checking. Okay, then what is the double checked? Okay. If we will store a singleton object which are not clonable in a hash map, and later will clone the hash map. Even you can clone the hash map, but the object inside the hash map is not clonable, and if you are throwing exception, it will throw exception. Or if you are returning the same instance, it will return the same instance, because that object's clone method is overridden accordingly. So I think I have done with most, or I think almost of the questions that are related to this session. Hema Bindu has asked another question related to double check. Does double check degrade the performance? Okay, let me explain it again. See, there is no such condition over here. It will work perfectly because this is synchronized block. But think of 100 of threads simultaneously accessing get instance method. Only one thread will be given access inside synchronized block. Remaining threads will be waiting for their turn. So this is a bottleneck. Synchronized block or synchronized method always have overhead much more than if condition. So if we have this double checking, it will, suppose there are 100 threads, only one thread will be given access to synchronized block. Remaining 99 threads, if the object is already present, will bypass the synchronized block. So this is not a performance degradation. This is performance improvement. So I think most of the
most of the questions are answered. So now I think we can conclude the session.
Yeah. Okay. So thanks everyone. So thanks for your patience. Thank you.
Thanks, Mr. Hemant Kumar Dugar. It was really an informative session. We got very good feedback from the participants. So thank you so much again from TechGeek team. Thank you. And we would also like to thank all the attendees and participants for the good response for this session.